Hi, welcome to the last of the bunch. In this video, I'm going to go over questions 3 and 4 for the second review sheet that's going to prepare you for the exam on Wednesday. All right, so let's go through question 3, 3.1. 3.1 says find the recursive formula for the number of squares in each figure. So let's have a look. So the first number is going to be 1, and then after that, we can see that we're adding 1 square to each of north, south, west, and east. So again, here from the previous figure, we're adding 1 square to each side of north, south, west, west, and east. So we're basically adding 4 squares to the previous figure to get the next figure. So an is going to be an minus 1 plus 4. All right, to find the explicit formula, looking at the recursive formula, we can actually identify that this is an arithmetic sequence. So we can use the formula, which is a plus n minus 1d. We can now substitute the first number, a equals 1, and d is the common difference, which is going to be plus 4. And then if we simplify, we get 4n minus 3. And then to find the number of squares in the 50th figure, it's not too hard. You can substitute n equals 50, and then literally just calculate what this number is going to be. And in this case, we get 4 times 50 minus 3, which is 197. All right, for question 3, find the recursive formula for the perimeter of the shape in each figure. So here we have the table. Here we have 4 for the perimeter, so we have 4 here. For this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, and for the third one, if you count, you can see that you actually get 20. One easy way of seeing how to find the recursive formula here is every time we move on to the next figure, we're adding 3 per square for because those are the ones that actually count towards the perimeter. So that's 3 times 4. So we're adding 12. And in the previous figure, these counted towards the perimeter, but they no longer do in this figure. So we're subtracting 4. So what we're doing is when we move on to the next figure, we add 12 and we subtract 4. So overall, we're actually adding 8. It's going to be the same here. We're adding 12 and we're subtracting 4. So overall, we're adding 8. So we can see that this is going to be an arithmetic sequence with a common difference of 8. So for the recursive formula, the first number is going to be 4, and then we get the nth number from the n minus 1th number by adding the common difference of 8. And then 3.4, we are expected to find the explicit formula and then find the perimeter in the 50th figure. So for the explicit formula, again, we know that this is going to be an arithmetic sequence. So we use the formula a plus n minus 1d. And if we actually plug the numbers in, a is 4 plus n minus 1 times the common difference is going to be 8. And if we simplify, we're going to get 8n minus 4. All right, once we have the explicit formula, we can find the 50th number pretty easily, and it's going to be simply just substituting n equals 50, and then we get 400 minus 4, which is 396. So the perimeter in the 50th figure is going to be 396. That is off the page, my bad. All right, so this was question 3, and then to wrap up this lecture, we're going to go through question 4. Okay, question 4 is rather involved. So every month, Jasmine gets $2,000. Oh, it's supposed to be $2,000 actually. $2,000 for paycheck, pays $500 for rent, spends $1,000 on food, and saves the rest in her bank account. All right, so every month, we have enough information to see how much Jasmine saves. So she gets $2,000 for paycheck, $500 for rent, $1,000 on food, which leaves her with $500. So every month, she's actually saving $500. So if her bank account balance was $4,000 when she started working, how much is going to be in her bank account after a year or after 12 months? Well, what does this 500 mean in this case? We actually just calculated the common difference. in the arithmetic progression we're going to have, because every month Jasmine is going to add $500 to a bank account, right? So yeah, we got to be a little careful here in a way that after 0th month, which is when she actually gets started, it's going to be 4,000. So the common mistake that I might see is n equals 1 and then having that number as 4,000, but that's not the case, because after 1 month, she's not going to have $4,000 because she would have saved 500 extra. So 0th month is what gives you 4,000, and the first month is going to give you 4,500. All right, so we know that this is the arithmetic sequence. So again, we can use the formula, this good old formula of a plus n minus 1 times d. Always remember that a actually means the first number when n equals 1. So when n equals 1, it's going to be 4,500 plus n minus 1 times d. D is the common difference, and we see that every month she's saving $500. So the common difference is 500. All right, I mean, you can simplify this if you want, but all we're interested in is how much she's going to have in her bank account after a year or after 12 months. So we can simply just substitute n equals 12 in this formula. Then we're going to get 4,500 plus 12 minus 1, which is 11, times 500. And then if you actually calculate this number, let's see, you're actually going to get $10,000. So Jasmine's going to have $10,000 in her bank account after a year. Only if life was this easy. All right, so that wraps up today's lecture. If you have any questions or comments, then you should definitely send me an email. Otherwise, I'll see you on Wednesday. Oh, actually, I do not have a lecture on Wednesday because from Wednesday to Friday, it's going to be the exams. So yeah, I guess I can say good luck with the exam, and I'll see you next Monday.